The minimum conditions for ringability, it is that a surface finish should be of 1 micro inch or better than this, and the flatness should be at least 5 micro inches. This is the condition for ringability. Now, the accessories, what are the accessories? The pictured accessories shown in the next slide. This is the slide of the accessory set of the gauge block. So, the pictured accessories shown in the next slide provide a set of holders and tools to extend the usefulness of the gauge block set. Now, the slip gauges, they are made from a select grade of carbide with hardness of 1500 Vickers hardness. Now, the long series slip gauges, they are made from high quality steel having cross section of 35 by 9 mm with holes for clamping two slips together. A gauge block stone is provided to remove nicks and burrs to maintain ringability, because if there will be nicks and burrs, then the adheringness of the blocks will be not as accurate and the ringability will be not very accurate. So, a gauge block stone is provided to remove the burrs and nicks from the gauge blocks. There are two ringing pads which are used to prepare a gauge block for ringing. As I have already told you, the first one is called as the oil pad, which applies a light layer of oil on the block, and the second one is the dry pad, which removes the extra oil from the block after the oil padding has been done. This is the gauge block accessory set I have already shown you, and next comes the grades. Now, these gauge blocks, they are available in various grades depending upon their intended use. Various grading standards include GISB 7506 1997 Japan, DIN 861 1980 Germany, ASME US BS 431 4311 Part 1 1993 UK. Now, these tolerances, they vary within the same grade as the thickness of the material increases. Now, next comes the gauge pins. Now, similar to the gauge blocks, these are the precision ground cylindrical bars for use in go no go gauges. Gauge rollers and balls. Now, these are supplied as sets of individual rollers or balls as used in roller or ball bearings. Now, next comes the tool maker's microscope. Now, a plain tools maker's microscope is primarily intended for a particular application, but on the other hand, a universal tool maker's microscope, it is used for a wide range of purposes or tasks. A tools maker's microscope, it is designed for measurement of parts of complex forms, that is, for example, profiles of external threads, tools, templates and gauges. It can also be used for measuring the center to center distance between the holes. Now, a general view of tool maker's microscope is shown in the next slide. So, this is the tool maker's microscope. Now, a heavy hollow base, it accommodates the illuminating unit. Now, on the top surface of the base, you can see that the work table is carried and it is supported on the balls. Workpiece is on the top surface of the base and it is supported on the balls and it is controlled by micrometer screws. You can see that there are two screws, one is front slide micrometer screw and another one is the cross slide micrometer screw. Now, the projection from the rear of the base is done through a column. There is a vertical column which carries a microscopic unit. So, microscopic unit, it is being attached to the vertical column and the various interchangeable eyepieces are also seen. Now, the magnification given depends on the microscopic objective. However, additional magnifying attachments are also supplied which increase the magnification from 10x to 100x. Now, in order to adapt the apparatus to deal with a variety of works, various additional attachments may be fitted to the work table. All these attachments, they are available for clamping the workpiece. Now, generally V blocks are used for this purpose. Now, there are screws, micrometer screws being provided. So, the linear movement of the table, it is being controlled by the linear micrometer screw, which is having a movement range of 25 mm and reading up to 0.001 mm. Now, there are several detachable and interchangeable eyepieces units available. Now, next comes the application of tool maker's microscope. For the first application is that is the determination of the relative positions, means it is used for the determination of the relative position of various points on the workpiece by measuring the travelling distance from one point to the second point. Next comes the measurement of angles, means with the help of the protractor eyepiece we can measure the angle with the help of the tool maker's microscope. Third one is the comparison purposes. A tool maker's microscope, it is also used for comparison of various thread forms, measurement of pitch and effective diameters of the threads. Next one is the comparison with the scale, means the comparison of enlarged projected images with the scale are also done in a tool maker's microscope. Now, next comes the sign bar. Now, it consists of a hardened precision ground body with two precision ground cylinders fixed at the ends. So, this is the sign bar. The distance between the two centers of the cylinders, it is precisely controlled, and on the top of the bar it is parallel to a line to the centers of the two rollers, means the top of the bar is parallel with the line which is passing through the centers of the two rollers, and the dimensions between the two rollers, it is chosen to be a whole number, because it is used as a hypotenuse when a triangle is being formed. So, the image which I have already shown, it shows a 10 inch and a 100 mm sign bar. Now, when a sign bar is placed on a level surface, the top edge will be parallel to that surface, means the top edge of that of the sign bar, it will be always be parallel to the surface which we are measuring. Now, if one roller is raised by a known distance by using the gauge blocks, then the top edge of the bar will be tilted by the same amount, forming an angle, and that angle, it is called a sign angle. So, then the hypotenuse, we already know it is a constant dimension which is known to us, it may be 100 mm or 10 inches. So, the height is obtained from the dimension between the bottom of one roller and the table's surface. So, we can determine the height by using the sine formula, sine theta is equal to perpendicular upon hypotenuse. If sine theta is known and hypotenuse is known, which is the fixed dimension, then we can calculate the height of that. So, this is the how we calculate the height. The angle is calculated by using the sine rule, and the sine angle, it is equal to opposite upon or perpendicular upon hypotenuse. So, what is the principle of sign bar? The angles are measured using a sign bar with the help of the gauge blocks and a dial gauge. Now, the aim of the measurement is to make the surface horizontal on which we are placing the dial gauge or a spirit level. The surface should be horizontal. Now, for example, to measure the angle of a wedge, the wedge is placed on a horizontal table, and the sign bar is placed over the inclined surface of the wedge. Now, at this position, what will happen? The top surface of the sign bar is inclined as the same amount of the wedge, as we are placing the sign bar on the wedge. So, how much inclination is of the wedge, that will be the inclination of the sine bar. Now, with the help of gauge blocks, we will make that surface horizontal, because earlier it was inclined, as the wedge is inclined. Now, we are using the gauge blocks to make that surface horizontal, because reading will be only possible when the surface is horizontal. Now, the sign of the angle of inclination of the wedge is the ratio of the height of the gauge block used and the distance between the centers of the cylinders. Because if the height of the gauge blocks is known and the distance between the centers of the cylinder, which is also known, we can calculate the sine angle, how much is the angle of the wedge. This is how we can calculate the angle of inclination of wedge or any object if height is known and distance between the center of cylinders is known. So, this is the sine bar, this is the reference surface, and the sine bar it is placed, it is made horizontal with the workpiece. This is how we measure the angle. As shown in the diagram, we are using the gauge blocks to make the sine bar horizontal, and if height is known and the distance E is known, we can calculate the sine angle or angle of inclination of the wedge. Now, the sine center, a special type of sine bar is the sine center, which is used for conical objects having male and female parts. And the limitation of the sine center is that it cannot measure the angle which is more than 45 degrees. It can only measure the angle which is less than 45. Sine table, it is used to measure angles of large workpieces. It is the most convenient and accurate design for heavy workpieces. Now, the sine block, now they are the heavy duty fixtures for holding work that must be set to precise angles for layout purposes or for machining purposes. Now, the sine blocks, they are made up of high quality alloy steel. They are heat treated for maximum stability and wear resistance. So, next comes the angle gauge. Now, an angle gauge measures the angle of a fixed or worked object relative to large object. Means angle is measured with respect to the large object. Angle of the small object is being measured with respect to larger object. Now, the three most common types of angle gauges are, they are used in the forest department, woodworking by the carpenters, and engineering. The one thing it is common that all the gauges, they have same basic thing, that is they just do it in different ways. Now, first one, in each case a single object, it is usually a tree or a saw blade or a fastener. It has its angle checked relative to the large piece to which it is attached, such as the ground or a work surface. This is the angle gauge. All the angle gauges are being shown. This is the about the woodworkers, how woodworkers do with the check the angle of the saw blades for operating purposes, and in engineering cases how the fasteners are being they are synchronized with the help of these angle gauges. They are available in sets only. Angle gauges are, angle blocks are they available in sets. Application of angle blocks, they are used for checking the accuracy of the rotating table. They are used for setting the revolving work holding tables. They are used for inspection purposes and providing reference angles. Clinometer is again used for measuring the angles of the slope. This is the diagram showing clinometer, and this is the summary. We have so far discussed various items. Thanks.